Hello, today we're going to resolve LeetCode daily problem number 2444, count subarrays with fixed bounds. So it is a hard problem in which we are given an array nums and two integers, minK and maxK. So we have a fixed bound subarray of nums. It's a subarray that satisfies the following conditions. The minimum value in the subarray is equal to minK, and the maximum value in subarray is equal to maxK. So we should return the number of fixed subarrays, and as we understand from April theme, it will be another count, another return of count. So a subarray is contiguous part of an array. And here we give an example where we have an array 1, 3, 5, 2, 7, 5, and we have minK 1, maxK 5. So the idea is here that both 1 and 5 should be present, but none of the elements should be bigger than that. So fixed bound subarrays are 1, 3, 5, and 1, 3, 5, 2. So the idea is here is in that we should have 1 because the minimum 1. We cannot include 7 to include another 5 because 7 is bigger than 5. That's why only possible solution is where is 1 and where is 5. Now let's think about more creatively about this problem. Imagine that you're on treasure hunt in a long hallway of chests, numbered from left to right. So each chest might contain a ruby, value minK, or emerald, value maxK, or some other trinket. You're only allowed to open contiguous run of chests. So, as you understand, first, no chest in your run is cursed. Its value falls outside safe range of minK and maxK. Second, you find at least one ruby and at least one emerald. One ruby, one emerald. So at least one minK and maxK. So every time you pick a right-hand chest, you want to quickly know how many starting points to its left would form a valid run ending here. So instead of checking every possible start with nested loop, you keep 3 markets. And we can start describing them. First will be our main k-index, which will be equal to maxk index, which will be equal to outOfBoundsIdx index, and all of them equal to -1. Here the idea that we track the indexes and we track outOfBoundary. So min will be represented the last emerald you saw, ruby the last minK the last ruby you saw, and outOfBoundary last cursed chest you hit. You cannot start before this. Now at chest index I, any run starting after outOfBoundary x and ending at I is valid if it includes both ruby and emerald, which means it must start at or before the earliest of the 2 last seen ruby or emerald position. The number of those starts simply the smallest value of indexes minK index, maxK index minus outOfBoundary. And that is one calculation. And move on, no backtracking needed. So as you understand from the story, we will use sliding window. We'll make one pass, it's y time complexity will be big of n, and span complexity will be big of 1, as we only will have 4 integers and nothing else. 1 to calculate our count and calculate the index of minK, the index maxK, and the index of all that are outside of boundaries. Pretty easy. Now, the next steps will be for I, which will represent index, and where, which will represent value. In nums, now we will check if our value is less than minK or our value bigger than maxK. If so, we found our out boundary index. Next check we need to make to check the following condition about if it's minK or maxK. So if it's minK, then we find our minK index. If value equal to maxK, then we find maxK index. Now we need to know where to start. For that, look for value start will be simple equal to minimum of minK index and maxK index. Now our count will be incremented by max of 0, valid start, and minus out of bounds index. Pretty easy, but hard to understand. Let's path it and let's submit. Pretty efficient. So let's now move to TypeScript description of this problem. And TypeScript, we will do almost the same, but there will be slightly different. So we will use let count equal to 0. We will return count. Then we cannot assign all elements as we did in Python. We will do x, then maxK index be equal to -1 and out of bound index which will also equal -1. We will start with regular for loop for let I equal 0. I will add in nums length and I will be incremented. Now we need our const value which will equal to nums I for nums in 0 position. And pretty the same, we will check if our value is less than minK or if our value bigger than maxK. If it's both true, we found our out of boundary index, which will be equal to I. Then we make another conditions to check value equal to minK. If it's true, then if our minK index it should be equal to I. If value equal to maxK, then we found our maxK index, which will be equal to I. And here we will look for valid start, it will be equal math min of chi index and max k index. Now we will return count plus incremented by math max 0 valid start minus out of boundary index. Slightly different as we need to add math and we need to declare variables before assigning them. But logic pretty the same and it's pretty efficient. So again, returning back to our problem, from the description of the problem we understand that we need to search for specific values, specific boundaries, and we need to check all possibilities using this variant. That's why it's important to look for indexes of min, max, and outer boundaries. Because if we found outer boundaries, it wouldn't be impossible to complete our array. For example, like here we have 7, which makes it impossible. And other way, we should include both 1 and 5. That's why we can create array with 1, 3, 5, and we can create array with 1, 3, 5, 2. But 7 is bigger, we cannot include. And for example, we cannot make array 3, 5 because 3 will be bigger than 1, which is our minimum value that must be present. And that's why with nums of 1, 1, 1, min k equal 1 max k 2 is 10, because we can create any combination. We can create 1, we can create 1, 1, we can create 1, 1, 1, we can create all 4 of them. Then we can start with another index and we can combine in every possible way to 10 times. So all combination of indexes. So the idea here is to understand how we make this sliding window that included our boundaries, and we just slide it once through entire array. So thank you for your attention. If you have any question, feel free to leave them down below. Have a nice day. Bye.